Welcome to the Hands-On AI channel. I'm Ivy. Starting today, we'll take you step by step through building a variety of AI-powered product features using real-world data from an e-commerce website. To begin, let's talk about the dataset. We're using the Amazon Reviews dataset provided by the Macaulay Lab at UC San Diego. The latest version, released in 2023, contains over 500 million records, a scale that allows us to demonstrate how to build large-scale AI systems, including search, recommendation, conversational AI, and more. The link to the dataset will be provided in the video description. Once we've downloaded the dataset, we'll begin with exploratory data analysis. We'll be using the Python ecosystem to build everything going forward. You can use pip, conda, PDM, or whichever tool you're most comfortable with to install the required Python packages. Let's start by installing JupyterLab and Polars. JupyterLab is a user-friendly, interactive environment for data analysis. It allows us to visualize results in real time, making it especially useful for data scientists and machine learning engineers who want to explore data quickly. We're using Polars in this project because it offers significantly better performance than Pandas for large datasets, at least on our end. That said, you can also use Pandas to perform similar data manipulation tasks if you prefer. All right, once everything is ready, let's launch JupyterLab and dive into some simple code. We'll start by importing Polars, a lightning-fast data frame library that's perfect for this kind of exploratory data analysis. Next, let's load our first dataset using Polars. This dataset is in JSON lines format and comes from Amazon's clothing, shoes, and jewelry category, provided by the Macaulay Lab. After loading, we can see that the dataset contains over 66 million reviews, confirming that this is one of Amazon's largest and most active product categories. The dataset includes 10 fields, such as review rating, title, text, image, etc. Let's explore how many unique users contributed to the dataset. By grouping the data by user ID, we find that there are about 22.5 million unique users. On average, each user submitted approximately 3 reviews. Now, let's switch to the second dataset, the metadata for more than 7 million products, which includes product title, average rating, total number of ratings, features, description, etc. We load this metadata using a clearly defined Polars schema, ensuring the structure is strictly enforced and easy to work with. Using Polars' fast filtering capabilities, we can easily find products related to sunglasses by searching in the title field. As you can see, the filtering completes in just a little over 300 milliseconds, given that Polars searched more than 7 million records. It's impressively fast. While Polars is highly efficient for in-memory data processing, however, it's not designed for large-scale distributed services, and its filtering capabilities are limited to exact or keyword-based matches. In the next video, we will show how to build a basic search engine on top of this dataset. Although we call it basic, it's already very powerful in practice. Make sure to subscribe so you don't miss out on the upcoming videos.